要那个出名的那几间 UTM
有 ITM 会跑吗？
有 ITM， 你这有点低。你要改叫我们带一个那个305杠片。
喂，输了啊！
哦，因为我们请那这边就可以申请，但如果你真的申请的话，是直接 reject 掉还是？
你说你什么？
那如果你
我都讲个 P 线的。
你其实个全部放有 ITM 进去。
哦，你找事情啊！那个，我看你就在社会大学了，University Masyarakat。
有没有
？Okay, next. Reflection at a spherical surface. Okay, we have seen the formula for mirror, lens, lens not yet. Now we're going to look at lens first, yeah? Lens, that is number 4. Application for reflection is lens, number 1. Now our lens, we have two types. Convex lens, okay? Number 1, convex lens has a shape that is bulged out at both sides. We use it as our reference line, also called the principal axis. So now this lens has two surfaces, one in the left, another one on the right hand side. Now we draw this one a thick lens. This is extremely thick. Normally such a thick lens is actually useless. Okay, so our lens, in this case, we will draw a vertical line passing through the edge of the lens. This is called the center of the lens. This is the first surface, okay, first surface, and this one is the second surface. And then we have two radius to talk about. This is the first radius, surface of the first surface, radius of the first surface, and this one here is the radius of the second surface, R2. And to draw that surface, you need to have a point called C. This is a center of curvature, C point. This is a center of curvature, C2. That's the center of the lens. So this is the shape of the lens of convex lens. Now convex lenses can be categorized into more categories. This type, if the R1, R2 are exactly the same, this one is called a biconvex. Okay, biconvex means both sides symmetrical. Now the second type is one side flat, another side is a curved surface, convex surface. So this one is flat. Flat we call plano. Plano actually in Greek is called plano, and this one is convex. So we have plano, convex lens. Okay, plano, convex. So plano on that side, your R2 is normally equal to infinity. R1 any value that is positive. Okay, that one is the convex. Now another type is this side is the same, and this side also have a surface that looks actually quite similar. Except if you look at the radius of curvature, there are two radius of curvature. One is a 1, we call the R2. Another one is your R1. Your R1 actually is at a different position. And this R1 is normally larger than R2. In that case, this is called convex meniscus. Okay, convex meniscus. If you look at the physical appearance, the outside curves more than the one inside, right? It curves more than the one inside. So that's why R1 is considered larger than R2. So these are the category of convex lenses. Okay, convex lenses. Now, the second category is our concave lens. Concave lens have the opposite appearance compared to the convex. So we have 1, 2. This one have to swing it. Right. Like that. is this one is biconvex, both sides the same. Okay, both sides the same. So we have radius. The C1 is here. This is the C2. So this one will be your R1, and this one is your R2. So first or best, second, we always follow the left hand side, go to the right hand side. But you can do right to the left also, doesn't matter. But as long as you are consistent, it's okay. This one here is planar concave. Okay, one side flat. So this is biconcave. This one is planar concave. And this one here is the opposite of the next one. Okay? If we flip this one over, compared to this one, just now we said the outside curve more than the one inside. If you flip this one over, you realize that the inside curve more than the outside, right? See that? 它的外面比较平过它的里面是。So that one is the opposite of this one. So this one is called concave meniscus. Okay, concave meniscus. Well, all these lengths in our study here, we will consider them as thin lengths. Okay. Now, how do you categorize thin lengths? There must be some category to categorize them thin and thick. Okay. So if thick we know lah, extremely thick. But thin length there must be a certain way. Well, a rough category. How to categorize them is by looking at the diameter of the length, okay, the ratio compared to the thickness. This is the big D, the diameter. If from the front you see that big, right? And then compared to the thickness of the length. If your thickness of the length T over D multiplied by 100% less than 10%, well, we can roughly assume this one as thin length. Okay, assume the thickness. Anything larger than that is not considered as thin length. So if we consider thick, but this one we assume one thing. You must consider the whole size of the length. You couldn't go so So you consider this one is the D and not the D. In that case, the D divided by the T divided by the big D can be like, for example, 2 times, right? So what we want is you have the whole shape of the length. The edge here, with the sharp edge and the next sharp edge is the diameter, and at the biggest part of your length, that one is considered as a T. So as long as this one stays, you can consider roughly this one to be thin lenses. Okay? 大概是8 right? So different type of lens, we actually have different application. So mostly we don't use one single lens to make optical equipment. Mostly we combine them. Okay? We combine them to form different or to achieve different results. For example, if you look at camera, definitely we have a few. But if your spectacles maybe mostly are this type. Okay? This type or that type. But depends, sometimes it's this type. But until you wear this one, you are still okay. If you are wearing this one, it's better don't use spectacle anymore. Straight away use a magnifying glass. Okay? So it's much cheaper than your glasses. Okay? So why the glasses are so expensive? Because it's a process of grinding the glass. Nowadays, instead of glass, you can actually use hard plastic to form glass and to form the spectacle. They are much lighter so that you don't actually have the breathing effect. Okay? 好像压在鼻子这个鼻子上面很痛的。So plastic, of course, lighter, maybe cheaper, but plastic has one problem. Scratchable, right? 不小心就 scratch 到了，刮掉了，很容易刮掉了。OK， 所以如果 plastic 刮掉很容易啊，你放在火上面叮一下。不要太久了，这个心情。你没事吗？哦，没有，这个我是丢一般的。因为我看过人家拿去离子的，它去掉啊，你拿火来烧着，它油，然后颜色倒回去，我里面的颜色，因为它是暴晒在 UV 嘛，太阳照它生粉，所以拿来烧一下它的那个塑胶的粘性导进的油回去， 所以那个烧了会直接就坐上去了，就坐上去，再移至第三个出去。Alright, so that is our definition, the physical appearance of these 6 types of lenses. Okay, next one is lens drawing or the ray diagram drawing for both type of lenses. So we have the same problem when you use drawing, okay, the ray diagram for our lenses, because your lens have to be thin. Okay? So to solve that problem, we can actually use a technique. Now our lens, we know we got 2 types. One is convex. Okay? For convex lens, we can use a straight line with 2 arrows pointing away. This one is the symbol used. Another one is our thin concave lens. You can use the same straight line but with arrow pointing towards each other. This one is a symbol for concave. This one is a symbol for convex. Right? So using this one so that we don't have to follow exactly the reflection at all the surfaces. But when we come to thick lens, we have no choice but to follow the reflection at every surface that it has. So we use this method. So now we go to the diagram, ray diagram. Number 1A for convex lens. Okay. The first one again is U is more than 2F. Okay. Now easier than we use compass to draw it. This is my lens position, right? As long as this one is 90 degrees, you got no problem. But my ruler have a spirit level over there. I know that is definitely 90 degrees. Okay. So, of course, you can assume. Now, one way to draw exactly 90 degrees is in your exam. Okay? If you are asked to use drawing method, one way is to use your compass. That's why your compass must be with you all the time. Not all the time I've been doing. So you need to draw line. Okay? Like that, like that. I think you will like this one. That's why you use this method. So this method will ensure that you get exactly 90 degrees. So that means my horizontal line is actually not horizontal. Okay? But at least I know that they are 90 degrees with each other. Okay? So that one is a fact. So that when I draw that, I don't have any problem anymore. 这些东西好久不见啊！还有画30度、45度、90度那些，还记得吗？我是去。对，这个太久了。No, lens is accumulative. We cannot say from 4, from 5, forget about it. 哦，对。I thought you want to enter chemical engineering or industry? Or bio resource? 那个有关系吗？哦，lens 嘛。Don't tell me when you take chemical engineering, you forgot about. 老师，你有那个 chemist study 以后不是啊 ？chemist study 以后 ，chemist what？ 以后啊，以后。I think I have somewhere. Okay. Now this is our convex lens. Okay, convex lens. Now let's assume we have the focus point like this. This is union. Okay, so assume this is 10, so it is 2.5 here, 2.5 here. So this is the F, this is 2F, another one here on the other side. Now we have to remember one thing. If you put the object on the left hand side and the image appear on the right hand side, that is considered normal for lenses. Mirror is different. Mirror, if you put your object on the left hand side, the image appear to be the same side, that is normal. That's what they call real event. But if it's behind, like this case, image supposed to be here, but image form on the same side as your object, then that is virtual. Okay? So we have to always remember, and some of the word sometimes is convincing. When you read question, make sure you read the whole thing, underline them, especially the word lens or mirror. Okay? Now we put an object here. This is an object. Same thing. The distance from O to the center of lens is U. This one here. So we have three lines to draw. First one. This one penetrate through the lens and go to the focus point. Same like what happened to your mirror, it reflected back to the focus point, but this one is reflected towards the focus point. Right there, number one. Number two, center of the lens here. Directly passing through the center without any change of direction. Now we already know where is the image position. This is our image position. Okay? And the third line is passing through the focus point in front of the lens, and after that become parallel, okay, with the focus point. Actually, with the line. Okay? Okay? They are together, right? Assume together. Okay. So that is the first one. So look at the characteristic of the image. Number one, this is real. Same like you use a lens tomorrow if the sunshine is strong, put a lens and put your hand behind and find the strongest spot and try to smell something on your hand. It's burning. So this is real. Number two, inverted. And number three is diminished. Okay? Now you can see that actually the sequence are the same as a mirror. Right? So next one, number two. Number two now is U is larger than F, but between 2F. Now this is the same length here. X. Okay, so I have this 5. This is okay. So this is F to F. So now I change a little bit. Just now I use the difference here. F and 2F. So the object now is here. Okay. O. Next step. Light ray, parallel, go to focus point. Okay. Number one. Number two, center. Okay. After that, through the center, go directly. Roughly the position of the image, and then the third one is passing through this, hit the lens, and then become parallel. That is the third one. So this is 1, this is 2. So that is the position of the image. So characteristic, number 1, real, number 2, inverted, number 3, enlarged. Okay, let's enlarge. What if I put the object at 2F? Where is the image? Same story, right? The image is at 2F behind the lens. Okay, so that one is our second drawing. I'll go to the next drawing. U is less than F. When U is less than F, we have some special condition. I'm going to draw my lens here. This is F to F. I think this on the other side also. Okay, object is here, not too near. This is the object O. Line. Parallel. one passing through the center of the lens and then don't coincide behind. So I have to extrapolate the line to the front of the lens. Okay, so that is where they meet. This is your virtual image. Okay, that's a virtual image. Now, how about the third line? Right? Third line, huh?
设计一个人前面。
You use this one, right? See? So here, the light coming here, reflection, parallel. Okay, parallel like that. But if you trace a line to the front, they're supposed to meet in front. Purely equally. So this is 1, 2, 3. So characteristic is number 1, virtual. Number 2, upright. And number 3, enlarged. Okay, so that is the 3 category of the ray drawing for our convex lens. Next one is the only drawing for our category number 2 is the concave lens. So for concave lens, anywhere you put, you get the same result. Okay, you get the same result. Let's say we have a concave lens here. Okay, concave lens is symbol like that. Now, and 15, 2F, this is F, this is F, this is 2F. Normally, the F value is considered negative for contact lens. Now, let's say we put it somewhere here. That is our object. Our first line, parallel. After that, what happens? It diverges away, right? Diverges away since the light coming from here. So, still related. Anything parallel is always related to the focus point. Okay? So, diverging. Okay, diverging. That is number 1. Number 2, passing through the center of the lens, no changes in direction. Okay, number 2. So we already know the position of the image, which is here. This is a virtual image. And then next one is the line that passes through the front focus, right? No, the focus behind. See the focus behind here. So this is what we do. We draw a line, hit the lens, and then become parallel. Okay, become parallel. If you trace back, you get the same point. So that is okay. So characteristic. Well, this is virtual. This one is upright, and it is all the time. It is exactly the same. Okay. Well, the formula that we're going to use on this lens condition is exactly the same for mirror, except for your lens or lenses, you don't have the F equal to half R because they don't have curvature on only one side. So we call that one the lens equation. So the lens equation is only 1 over U plus 1 over B equal to 1 over F. Okay? Later we're going to prove another equation. Okay? Now, when the U is the object distance, normally object distance is the object to the center of the lens. That's why we're going to assume that the lens is thin, or else the thickness of the lens will be considered. And then B is the image distance. And the M is the focal length. Okay, focal length. So equation, knowing the equation is one thing, but solving problem with one single length is also not a problem. Solving of two lengths together. We call that one a double length calculation. So first we look at example 1, which is only for one single length. So it's not a problem at all, right? So let's look at the most simplest example. An object or a candle. Okay? A candle is placed at 80 centimeters from a convex lens. Okay? When the question mentions convex lens without any other things, it assumes it's a biconvex lens. Okay? A candle is placed at 80 cm from a convex lens of focal length 25 centimeters. Find the magnification or find the characteristic, okay, of the image form. Alright? So first we draw a simple diagram about this. So you can actually put your candle on the left or the right, it doesn't matter, but as long as you are consistent with that, it's okay. So this is a convex lens, so we have this symbol. We write the focal length somewhere at the top or at the bottom equal to 25 centimeters in bracket if possible. Then we have this object placed here. This is a candle. So with a U value of 80.0 centimeters, use a object symbol. Then find where is the location of the image. Well, sometimes in objective, you can guess the answer already. 80 divided by 25, how many times? More than 2, right? That means you are placing it at what? At more than 2F condition, right? More than 2F, you know the condition will be real, inverted, and diminished. Okay? Diminished. So look for answer that is smaller than the size, okay? But you're not asked for the size. So you know that the distance should be nearer than 80 centimeters. Okay? Nearer than 80 centimeters. Okay? But anyway, we calculate to show the characteristic. To find the characteristic mean, we have to tell whether it is real, upright or inverted, or is it diminished or enlarged. Okay? So the solution is here. First, list down what you are given. 80 centimeters, focal length is 25 centimeters. So we use the length equation to solve the B value. Okay, 1 over 80 plus 1 over B equal to 1 over 25. Someone calculate the B value. This one definitely is positive. Okay, Dr. Lawrence. 36.4 centimeters. 数学家对吗？
他们这是数学家，还是数学知识？
不要闲了。Next, what can V tell you? Now you remember V depends on if your V is behind here is considered positive, if in front there is negative. You can treat this one as a coordinate system, positive, negative, the other side. Okay? So that's why some books you refer to, your length equation actually looks like this. 1 over M is equal to 1 over B minus 1 over U. Some books use this system. So why negative? Because they assume the center of the length is a center of coordinate. Anything to the right positive, anything to the left negative. So if in this case the object is placed on the negative 80, you put this one negative 80, it goes back to the same position, plus 80, right? Okay, but our system, we don't use that equation. You can define everything is actually relative. Everything is relative. It depends on where you choose the location. Okay? Now from here we can make some actually there are choices we can make here. V if it is positive or when V is negative. If V is positive, it is a real image. If V is negative, it is a virtual image. It comes out automatically when we derive that equation. 1 over U plus 1 over V equal to 1 over F. So in that case, what can you tell me? This is a real image. Positive 36.4. Right? Next one is to calculate to tell whether it is inverted or upright or diminish or enlarge, we need to calculate the magnification. This magnification in optics we have two types. One is angular magnification, another one is lateral magnification or linear magnification. Linear or lateral magnification. Now I don't know how your teacher teach you. My linear magnification m is equal to negative b over u. Okay? If you learn the magnification of positive b over u, you are adopting that system just now. So what is the equation?
可能被课标跟课本
没有知道是
这样，被课标。
You better follow this one because if you don't follow this negative sign, when you come to double lens calculation, you're going to have a lot of problems. Okay? A lot of headache in defining where is the position of the image. Now we calculate our n value. Negative b over u is equal to negative, this one is 36.4 divided by your u is 80. Okay, again. Notice, calculate negative 0.1. 0.45. Okay. Negative 0.455. From the magnification, we can give two information. Info number one. Okay. Info number one is we look at whether the m is positive or negative. Okay. So if it is positive, if it is positive, that means it is upright. If it is negative, then it is inverted. You see, that is an important information. So in this case, because it is positive, right, so we know the image is inverted. Right? Information number one. Information number two is the magnitude of your m. If your magnitude of the m is larger than 0, that means it's positive, right? So this one is enlarged. If your m is equal to 0, it's equal to same size. And the last one is m less than 0.
可是不可能
不是
会是
一呢？
sorry, equal to 1. I'm just testing for you only.
我相信。
This one what? Diminish. Right? So that one is the information. So now since the magnitude here is less than 1, so we know that it is smaller. Okay? Diminish. So these are the characteristics of the image. But you need to prove by using these figures. Okay? So now you tell me if your n formula doesn't have a negative sign, you get magnification equal to positive 0.45. How are you going to justify that it is inverted? Unless you memorize. See, we don't want memorize. Because when you form the equation, magnification actually you use things like this. You put something here, and then you have light passing through, you form an image here. Now remember, left is negative, right is positive, up is positive, down is negative, right? You are actually taking ratio because the angle should be the same here. So you have a size of the image, this is called an object, and this is the size of the image negative. And then you have this length, remember that length? This one is u, this one is b, right? So the ratio should be the same, the ratio would be the same. So if we take the ratio, it is what? The magnification is equal to, if you take this one as the center of your coordinate, you are using b divided by u, right? So it's a b divided by u, but you use negative, right? Okay. Negative. Now, another one is, you can also use the height, right? Height of image, image, which is negative, right? Divided by h0. So you see, it should have a negative sign. So sometimes we just wonder why some of the books show the equation only have the positive sign. Huh? Oh yeah, no, sorry. This one is larger than 1, smaller, equal to 1, smaller than 1. is the application of the same law, same equation, but for double length. Okay, double length. Same method, except double length, we calculate 2 times. Okay? Twice. And then you must have a diagram to help you to place the location of the first and the second image. Example 2. Okay, we have 2 lenses. Start with 2 convex lenses. Okay. Now we have lens number 1 and lens number 2. Focal length f1 is, let's say, 30 centimeter. Focal length for number 2 is, let's say, 10. Sorry, this one is 45 centimeter. And the distance between them is d, which is, let's say, 20 centimeter. An object is placed at a distance of 40 centimeter. Nearer. Okay. This one is offset, and the u is equal to, if I put it at somewhere around f and 2f, so this one is, let's say, 40 centimeter. Okay. So find the characteristic of the final image form. Final image, that means you have more than one image. 2 images actually. Image number 1, image number 2. So we have 2 lenses here. So there are 2 sets of calculation. One for the first lens and the second one is for the second lens. So we start with the first lens. Everything with the first lens we use a subscript 1. For lens 1, okay? Use the same equation 1, 1, 1. Okay? Now, f1 you know is 30 because this one is convex lens, so automatically you put 30. Be careful with the symbol they use. Sometimes they only say there are 2 lenses, they didn't say one is convex, one is concave. You always forget about the negative sign. Okay? So 1 over u is 40. In this case, it's normal. It is on the left hand side. We assume cosine 1 over 40 plus 1 over v1 equal to 1 over 30. Okay, help me to get this value. Centimeters. 120 centimeters. So draw the image. This is your u1. Okay. Your u1 is equal to 40 centimeter. Your v1 is 120 cm behind the first lens. This is 20, so it should be somewhere here. And if you calculate the magnification, try first. Magnification negative v1 over u1, right? So negative 120 divided by 40. This one is negative 3, right? Negative 3. So negative means inverted. Somewhere here inverted, but 3 times means enlarged, isn't it? Enlarged. So now we know this distance is the v1, which is equal to 2 centimeter. And then the size is 3 times bigger than the original one. So this is the image number 1. Now we need to go to object lens number 2. Okay, lens number 2. For lens 2, same equation. Now this one u2 is what? u2 is the object distance from f2. It is v1, but your v1 is behind, so it's negative. Yes, negative. So this one is also your u2. Okay, u2. But because it's behind the lens 2, so you have a negative value. How much different? Sorry. This 120 is from here.
Oh yeah.
From here. So it's like this.
Yeah.
So your u2 is here. Your u2 is 120 minus 20, so 100 centimeter, negative 100 centimeter, because behind your lens number 2, minus 100 plus 1 over v2 equal to 1 over 45. Okay, calculate again. v2 31.03 positive. Okay. Now after this 31.03 over negative 100. Yeah, we can sum it up. Positive, right? Okay. Okay, can you draw the location of this image? Image number 2 now. Your V2 is positive, that means it's behind the lens again, so it is somewhere here now. Nearer than this one, right? So somewhere here, and it's positive, that means upright. Upright relative to what? Upright relative to this one, so it's still pointing in the same direction. That's why I use upright. Okay? It's not inverted, right? Upright, that means it's the same as this one, so except it is nearer and smaller. Smaller compared to this one. To know the actual size, this you have to calculate the total magnification, and this one is your V2, which is 31.03 centimeter. Okay? Now, to know the final condition, you need to calculate this. Total magnification is equal to M1 multiplied by M2. The theory actually comes from a two-dimensional matrix about this thing. So you don't learn the matrix. So you have negative 3 and then multiply by 0.310. Okay, what do you get? Negative 0.93. So that means this one here, this final image is only 93% the size of the original image. Okay? And then it is inverted. And some more it is real. Okay? So you need to look at these two values. Okay? The M total and the last V value. If I give you more than 2 lenses, 3, 4, 5, you will do the damn same thing over and over again until you have the last V value and the total magnification. So from here we can get number 1, it is real, remember? It is real. Number 2 is inverted. And number 3, it is diminished. Okay, that's it. That's how you do the double lens calculation. Understanding double lens calculation, you can do multiple lens problem, no problem. Okay? So, okay, so we finish for today. We continue on. So video will be about 3 hours video, no, 2.5 hours. 3. Okay. 这样解释为了在录在里面啊。